Howdy, folks. This is Kent Luffler, and I'm the photographer in the Department of Plant Pathology and Plant Microbiology at Cornell University. And I have bachelor's degrees in biology and from the University of Missouri, and also in biomedical photography from the Rochester Institute of Technology. And I've been working in the Department of Plant Pathology at Cornell since 1985, taking pictures of plant diseases and also a lot of insects. So Rachel McCarthy has asked me today to provide a lesson in photography, photography for diagnosis. And so we're going to go over today some basic photography principles. And anybody who is already a skilled photographer, you can plug in your earbuds right now and turn on your iPod. This will probably be kind of boring for you, but if you're not familiar with photography, then hopefully we'll have a few things that you might learn here. So we're going to start off today with, I can get to the, yes, there we go. So we're going to start out today with basic camera choices. Most of you probably already have a camera, but if you don't, you have a couple of choices in digital cameras. There's the point and shoot variety and also the digital SLR variety. Point and shoot cameras are usually lightweight. They don't have interchangeable lenses, whereas the digital SLR cameras are usually parts of huge systems of cameras with interchangeable lenses and flashes and all sorts of other attachments. So your first decision is what kind of camera to get. So if you're thinking of getting a point and shoot camera, the advantages are that they're usually small and lightweight. They're easy to carry. A lot of them will actually fold up so small you can slip them in your pocket. Uh, they usually have built-in lenses that have zoom and macro capabilities, and they're also relatively inexpensive. The disadvantages of the point-and-shoot cameras are that most of the features on them are automatic, and it's kind of difficult to override some of these automatic settings. So a lot of times you'll find that in weird lighting situations, it's hard to get good focus or a good exposure. But 90% of the time, I'd say these point and shoot cameras will give you a good exposure and good focus. It's only that 10% of the time when the lighting's kind of weird that you might have troubles. And these cameras are usually not part of expandable systems. You can't add extra lenses to them or extra flashes, so you're sort of stuck with what you have. Now, the digital SLR cameras are what I generally use and what I would recommend. The advantages to one of these systems is that there's many more automatic and manual settings that you can use on them. They have all sorts of features for any kind of lighting situation. And these are usually parts of large expandable systems. So you can buy more lenses, macro lenses, telephoto lenses, all sorts of flashes, bellows, all sorts of different things. And the disadvantages, though, are that they're larger, heavier, and more expensive. So you have to decide if you want something that you're going to be able to carry around easily and will work most of the time, like a point and shoot camera, or something that you're going to want to be a little more difficult to carry, cost you a little more money, but you're sort of guaranteed of getting better pictures. And in the future, if you want to expand your system, you'll be able to buy extra lenses and things for that camera. So that's the basic choice you need to make. And unfortunately, there are dozens of camera manufacturers, and each of those manufacturers have dozens of models on the market. So you just have to study what's new at the moment and see what's going to work best for you. This is sort of an example of a digital SLR camera system, some of the extra add-ons that you can add to your system, all sorts of lenses and flashes, some bellows. So this is the type of system you could use for a long period of time, and every time you run into a new situation, you should be able to purchase something that will help you solve that problem. Now, one of the things when you do decide on what camera to buy and you pick one up is make sure you save the instruction manual and study it. Like I mentioned earlier, there's dozens of different manufacturers, dozens of different camera models for each manufacturer, and they're all a little bit different. buttons are in different places, the terminology is different. So your camera manual is the only place where you'll be able to get all that information on your particular camera. So you're probably going to get tired of me hearing this today because I'll mention it numerous times, but make sure you study and save the instruction manual that came with your camera. Now there's a few camera settings and terminology that we should sort of get familiar with at first here. And these are, most cameras have the same terminology, but it is slightly different on some, so you'll want to check with your manual again. One of the settings is white balance. That's usually abbreviated as WB. And the default setting, as it comes from the manufacturer, will usually be on auto. And you could probably just leave it on auto and you'll never have any problems. ISO, or International Standards Organization, refers to the speed, or the, should we say, I guess the speed of the sensor in your camera. So that determines how much light is necessary to make an exposure. And a lot of the point and shoot cameras and some of the other even digital SLR cameras have an auto setting for ISO, and that's the way it is when it's shipped. I would generally like to do things manually. You could leave it on the auto and you probably won't have any problems. I generally set it somewhere between 100 and 400. Usually 400 is a good average setting for the ISO. That'll allow you to take pictures uh, probably indoors in low light, and also like in the shade outside, and also in the sun. So it's sort of a good overall setting, but the higher the ISO you use, sort of the grainier the picture will be. So I generally stick to 200 to 400 if at all possible. The resolution of your camera, you're going to want to leave it set at its highest possible resolution. This will probably be the way the camera is shipped. So if you have a 8 megapixel camera, you're going to want to use all of those 8 megapixels in the pictures when you take them. So leave that at the highest possible setting. Now the format that you're going to save your pictures, you have multiple options, especially with the digital SLRs. There might be up to a dozen different options. For just beginning photography and for what we're doing here with the diagnosis, I would put it in JPEG high, or some camera manufacturers call that fine. This will save the image as a JPEG, which is a compressed format, but if you have it on the high or the fine, it won't be compressed very much. A lot of these cameras have built-in flashes, and you're going to want to go back to your instruction manual and figure out how to turn the flash on and off. A lot of times with scientific photography, the flash on the camera is not a good thing to use. It'll just sort of wash out the image, especially when you're doing close-ups. So you're going to want to be able to turn that off. And some of the cameras, it's a little difficult to turn off, but there should be some kind of setting where you can do that. So make sure you know how to do that. And then focus, which we're going to talk about in a minute. You're going to want to find out where your camera focuses. Of course, it's important. You want the picture to be as sharp as possible, and you don't want to be focused on something that's not important in the picture. And then most of these cameras also have a macro setting on the lenses. So you're going to want to make sure you know how to use that macro setting by turning it on and off. So there's several factors that make up a good photograph. And these are all ones that we're going to go over in a few minutes. So you're going to want the picture to be sharply focused. You're going to want to have a good exposure. You don't want it to be too light or too dark. You're going to want to use the proper lighting. And by this I mean you're going to want the lighting to show whatever it is in the sample that you want to show. You want to either backlight or front light or side light. And we're going to talk about that in a few minutes. And then it's always good to take a series of pictures. When you're going to send off these pictures to a diagnostician, it's always good to have a series, like have a wide view of the specimen, like as it is in nature, and then maybe move closer and take some close-ups and macro, and even on the microscope, if you have a microscope in your lab. We're not going to talk about microscopy today, but that's something that will probably be mentioned in another one of these modules. So let's talk about focus first. Of course, you want the subject of your picture to be in focus. You want the diagnostician to be able to see what it is you want them to see. And one of the problems with digital cameras, especially the point and shoot ones, is that it's hard to determine where in the frame the focus is going to occur. On the left-hand picture here, you, that's we've made a mistake in the picture, and the focus is on the leaves behind the flower. So you want to reposition the focusing spot on your camera so that focus is on the flower itself. And to do this, again, you're going to have to go back to the information book that comes with your camera, and you're going to want to study the thing AF, which is autofocus, and the different modes that your camera uses. I can't really go into any detail about it because every camera is different, but some cameras have multiple spots that you can choose. You see over here on the right-hand side. And these are all settings that you can make in the menu of the camera. Some of them have a single spot that's just right in the middle. So you're going to have to read the instruction book on your camera and find out how the autofocus works. And then when you take the picture, make sure the autofocus point is on the specimen you're interested in. Now, another big problem with focus is camera movement. And there's two different types of camera movement. One of them is when you actually shake the camera when you're taking the picture, and the other one is if the specimen is moving, like on a windy day. So to prevent the camera shake when you're taking the picture, you could use a tripod. Most people find that tripods are, kind of not too easy to use, especially if you're out scouting and you have a lot of other equipment that you're carrying. So what you can do is when you take the picture, make sure you're sort of bracing yourself. You can lean against a tree or a doorway when you're taking the picture, or even if you kneel down and sort of hold your body kind of tight and the camera kind of tight when you're taking the picture, and hopefully that will reduce some of the camera shake. For anybody who's familiar with, a little more familiar with their camera, there's settings where you can increase the shutter speed. So you have decrease, so you have a shorter shutter speed when you take the picture. And that will allow less camera shake. And also, if you're photographing on a windy day, the best thing to do is just try to wait for the wind to die down, or somehow have someone else like hold the stalk of the flower or the specimen while you're taking the picture to reduce any wind. Now, next thing we're going to talk about is getting a proper exposure. And this is pretty basic. I think everybody understands what a good picture should look like, exposure-wise. But on the left-hand side here, you see that this is an underexposed picture. And there might be some detail, like in the shadow areas here, that a diagnostician might find important for diagnosing a problem. And it'd be too dark in an underexposed picture. And over here in an overexposed picture, you can see that, again, there might be some information, important information on a symptom that's lost in the overexposed areas. So we want to have something like the middle picture, sort of the Goldilocks picture that's just right. And there's several ways to go about doing this. We're going to go over a couple of them right now. The first one, most of these cameras have multiple exposure settings. And over here you can see this dial on the camera. There's all sorts of settings that you can, any of these are what control exposure. What I would recommend when you start out and for most general things is to set exposure on P, and this stands for programmed auto. In the programmed auto mode, the camera decides both the aperture of the lens and the shutter speed. And it uses all sorts of smart electronics and stuff to do this. It'll read the light, scene, and set everything for you. So it's a fully automatic setting. And what you're going to want to do is, again, go back to your guide, read how your camera handles the programmed auto setting, because it's different on every camera. Some you set it with a button, some you set it with a dial, some you set it on the menu on a touch screen. So just find out how to set it and set your camera for P. Now, usually it'll work probably 90% of the time you'll get a good exposure. And every time you take a picture, you're going to want to look at the picture in the back of the digital camera and just see if it looks right. See if it's, not overexposed or underexposed. The only thing is you can't really trust the image on the back of a camera because the LCD on the camera might be set to be a little bright or a little dark. So you can get a good idea of it just looking, but to really see if it's a good exposure, you're going to want to do one more thing. And this is, again, to go back to your user guide and see if your camera will display a histogram. Most digital cameras nowadays do, but some of the point and shoots, especially the cheaper point and shoots, might not. But almost all the digital SLRs will do this, and most of the advanced point and shoots will also. So a histogram is just a graph that shows you what value or tonality the different pixels are in your picture. And you can see over here on the right-hand side, there's these three graphs. Now, a histogram of a good exposure will look something like a bell curve. Most of the pixels will be in the midtones, which is in the middle of this graph right here. So you can quickly look at the graph, and if it looks something like this, you know you have good exposure. If you look at the graph and most of the pixels are shoved off to the left-hand side, that means your picture is probably going to be underexposed. And the pixels, you have mainly dark pixels in the picture. And if you see that the pixels are on the right graph, the graph here, they're pushed off to the right-hand side, that means your picture is probably going to be overexposed and most of the pixels are too bright. So in real life, this is what it might look like on the back of your camera. And you don't have to pay attention to these three colored histograms on the right. That's sort of overkill. What you're going to want to look at is the combined histogram. Right? So if you have a good exposure, you'll notice that it's a nice bell-shaped curve. So you can quickly look at the histogram. You can see, okay, it's sort of a bell-shaped curve. Most of the pixels are in the midtones. I can go on to the next picture. So again, in real life, this is what an overexposed histogram will look like. All the pixels are pushed over to the right-hand side. And over here in the bottom picture, you'll see that this is an underexposed picture where most of the pixels are pushed off to the left-hand side. So if you notice that you made an exposure and it's either overexposed or underexposed, then you're going to want to retake the picture but alter the exposure. And when you're in program mode, most cameras will have a button with this little plus and minus sign on it. And this is how you'll wind up either adding or subtracting exposure while you're in the programmed auto mode. So again, you're going to have to look at your information guide that came with your camera and see how your camera handles exposure compensation. Generally, it'll be a little button like this, and you'll push it and then move a dial, and you can either add or subtract exposure. And in this example, if we have a dark picture that's obviously underexposed, then we can add maybe one f-stop of light, one value, and take the picture, and it'll come out much better. So again, this is something you'll have to look at in your own camera manual and figure out how your camera does this. Okay, now let's talk a little bit about lighting. When you're outside, we'll just be talking about outside lighting today, not studio lighting. Most general, the easiest type of lighting is called front lighting. And this is where the sun is actually over your shoulder and it's illuminating whatever it is you want to photograph just directly from the front. And you can see the little stick figure here is taking a picture of this tree. And this is what front lighting would look like. It's usually really good for just to get a general view of a specimen to light it like it would be in nature. Now, if you move around to the other side of the tree, you'll be doing what's called backlighting if you're photographing into the sun. And for the most part, you don't get any detail in the specimen, so it's not going to be really useful for seeing detail. But you see a silhouette of the specimen against the bright sky or sun. And this might turn out to be important if you're looking at a tree that, one of the branches has no leaves and the others are fully leafed. This might be a good way to show that by showing the silhouette. Okay, and also backlighting can come in real handy if you're photographing things that are transparent like leaves, because then you can use the backlighting to see what's going on inside the leaf. So this is something you can just, when you're out in the field, you can just hold the leaf up to the sun or up to the sky and photograph it. You might need to use your exposure compensation to add a little exposure because the camera might want to make it a little darker. But go ahead and figure out how to do that. And sometimes, depending on the specimen you're photographing, this type of lighting might work really well. Now, often when you're photographing in the sun, the shadows that are created by the sun are kind of distracting. And when you're looking at something, it might hide, the shadows might hide something important that the diagnostician might need to see. So in the picture on the right here, you see these pine needles or spruce needles photographed in the full sun. And it looks like it does in real life, but there's a lot of shadows in here that might be hiding something important. So what you can do is you can actually make the shadow of yourself block the sun, and then take a picture of the specimen in the shade where you're blocking the sun. And you get a completely different looking picture, but in this one there's no shadows, and you can see all the spruce needles all the way down to the base. So this might be something you're going to want to do when you're out in the field photographing, especially close-ups. Try different types of things, create shadows, and photograph the specimen in the shade and see if it doesn't look a little. Another thing when you're photographing in the field is to think about the background of the picture. The picture on the left here you'll see is photographed against a field of other flowers, and it's really hard to pick out the foreground, your actual specimen, from the background. So if you just move a few feet over one side or the other and try to position the specimen against a background which is either darker or lighter or different color, then it's much easier to see the symptoms of the specimen. So when you're photographing things to send to a diagnostician, you're going to want to take a series of pictures, like a long picture of the specimen in the environment, say this tree next to the building here, and then move in a little closer, take a picture of, sort of the general symptoms that are in this tree. All these leaves are turning brown. And then also do a close-up. Close-up, it's always nice to put a scale in the picture and also a gray card, which we'll talk about in just a minute. So when you have a series of pictures like this, a diagnostician has a much better idea of how the specimen came from nature. In this case, you can see the tree is right next to this building, and big trucks and things park right next to it. So this might give the diagnostician a clue that, the damage to this tree is some kind of mechanical damage caused by its proximity to the building, and maybe not a disease. So as we mentioned before, when you're taking close-ups, it's always good to put a scale in the picture and a gray card. And these gray cards can be purchased quite cheaply. This is one of my favorite one, the Huaibao, and it's a small plastic piece that's this gray color, and it's waterproof. You can take it out in the field and it won't be damaged. And it has a scale built into it. So the gray card itself will come in handy when you're working on the picture on the computer afterwards, and we'll talk about that in just a minute. So when you get to post-processing your pictures, and this is what you do with the pictures on the computer after you've taken them, what you want to do is download the pictures from the camera to your computer, and then open up all the images in an image editing program. And I would highly recommend using either Adobe Photoshop or Photoshop Elements. The Photoshop Elements is sort of like a Photoshop Lite program. It's not as complicated or as expensive as the full version of Photoshop. These two programs are just sort of industry standards, and they have all the tools you'll ever need to work on your photographs. That's why I recommend them. And what you're going to want to do is edit out any of your pictures that are out of focus or blurred or exposed poorly. And you could do this in the field as you go, just delete the pictures if they're not good, or you can do this editing on the computer later. And in Photoshop or whatever other editing program you're using, you're going to want to use tools like levels to optimize the exposures. And then you're also going to want to reduce the file size before you email the file to the diagnostician. And we're going to go over a few of these right now. So let's use this picture as an example. This is a picture of a bristlecone pine taken out in California, and it's kind of overexposed. I'm sorry, it's underexposed. Yeah, it's very dark. So when you're looking at this on the computer, you say, well, it's not quite what I want. So what you can do in Photoshop, open up the picture in Photoshop, then under the image drop-down menu and adjustments, you'll see there's one of the tools is called levels. So if you open up levels, this is what we can use to adjust the exposure on this picture. Okay, so this is what the levels dialog box looks like. And what we're going to want to pay attention to is this top graph right here. And what this is looks just like the histogram on your camera, and that's because that's exactly what it is. It's a histogram telling you how all the pixels in the picture are located by tonality. On the left-hand side is dark or shadow pixels. Middle is the midtones or gray pixels, and on the right is the white pixels. So you see in this picture, because it's underexposed, most of the pixels are on the left-hand side down here in the dark area. So the nice thing about levels is that these sliders underneath, these little arrows, are adjustable. So what we're going to want to do is slide that white arrow over here to the edge of the graph. And if you notice that on your picture, if there was space between the dark slider and the graph, then you would want to slide the dark slider over also. On this picture, the dark slider is right at the edge of the graph, so we're going to leave it there. And you'll notice that all of a sudden the picture became a lot brighter. Okay, so now what we're going to want to do is adjust the middle slider. And this one you just do by eye. You move it back and forth until it looks right to you. And now just by making those two simple changes, this picture has gone from being underexposed and hard to see being a proper exposure. So for all your pictures, you're going to want to do this. Just open them up, look at the histogram and levels, and slide the sliders until they match the graph, and then move the midtone slider back and forth until the exposure looks right. Now you can also use levels to correct any color imbalances in your picture. And this is where the gray card is important. If you have put a gray card in your picture, a lot of times when you take pictures in the shade or some sort of different lighting situations, you're going to get a color cast to the picture. And if you want the diagnostician to see the proper color of your specimen, you're going to want to correct that. So what you do is you open up the picture in Photoshop again and open up levels. And on the right-hand side of the histogram here are three different eyedroppers. What you're going to want to do is pick the middle eyedropper and then click on the gray card. What'll happen is it'll work like it does in the bottom picture here. The gray card will be made gray, and the color balance of the picture will be brought back to the way it was supposed to be in real life. Oh, sorry about that. Okay, so the final thing you're going to want to do to your pictures after you've edited them and corrected the exposures is to reduce the file size so that you can email it into a diagnostician. And this can seem a little complicated, but we'll go over the steps you need to do this. Again, we're working in Adobe Photoshop. Other image editing programs might be slightly different, but they'll be pretty similar to this. So first you're going to want to open up your picture after you've done all the corrections and everything to it. and then go to the image drop-down menu, and there's something called image size. Open up image size, and this dialog box will open. And there's a lot of information on this box, so we'll just go over it step by step. At the very beginning, at the very top, it tells you how big your picture is in pixels. So this picture is 8.38 megapixels, or means 8.38 million pixels. And it also tells you the pixel dimensions, 2100 pixels width and 1395 height. Now the section below it will be how big this picture would be printed if you were to send it to a printer. If you send it to a printer, the printer would print it at a resolution of 300 pixels per inch at 7 by 4.65 inches. Now this is the way the picture came out of the camera. So what we're going to want to do is reduce the file size, make it smaller, so that you can send it to the diagnostician. And there's one other section in the image size dialog box down at the bottom. Just make sure all these three things are clicked. And you don't have to worry about what they are. Just make sure they're clicked when you're using image size. So now what we want to do is we'll change the resolution. So we change the resolution to 200 pixels per inch. And then we have size your picture, so it's about 7 inches on the longest dimension. So if it's a horizontal picture, make it 7 inches horizontally. If it's vertical, make it 7 inches vertically. And now when you'll notice, you'll notice that the pixel dimensions have been dropped almost in half in this situation. So what you do is when you get that done, get it sized the way down here the way we had it, and say OK. And now what you want to do is save the picture as a JPEG. So you do a save as, and then pick JPEG as your option. And use a setting of about 7 or maybe 8 in the image compression. So you'll notice over here that the size of the image now is only going to be 133 kilobytes. So originally this file was about 8 megabytes, and now it's only 133 kilobytes. So it'll be much better for emailing this into the diagnostician. There we go. So it's quite a bit smaller now. I don't know what that would be. Probably about 60 times smaller than the original file. So what you want to do is when you save this, make sure you save it into another folder so you're not saving it over your original picture, which is has the highest resolution. Okay, and then that's all you need to do, and those pictures you would send into your diagnostician, and hopefully they could tell you what the problem is with your specimen, or if you need to send in more samples for diagnosis. So in summary, what you want to do is decide what kind of camera, what kind of camera system you want to purchase, and make sure you save the instruction books and study it thoroughly, because every camera is different, every model is different, every manufacturer is different. So that's the only place where you're going to get the information on how to use your camera. So make sure you keep that. Strive to make sharply focused, well-exposed pictures, and use the proper type of lighting to make whatever it is on the specimen show up that you want the diagnostician to see. And take a series of pictures from the whole environment to macro and even micro if you have a microscope. Make sure you include a gray card and a scale, especially in the close-up pictures, because these will give the diagnostician a good idea of the size of the specimen. And then use an image processing program. Photoshop is what I recommend, or Photoshop Elements, to process the images. Reduce the file size so that it's nice and small for when you send it into the diagnostician. And then only send your best pictures in. Don't send a lot of pictures that are out of focus, blurry. And that should do it. hopefully that's given you some pointers on how to take better pictures. And we'll probably have a more advanced module of this later for anybody who's interested. So thank you for listening and have a good day.